Nice try. All right.
You think they confused if we go like this?
So I'm gonna wear ear protection. It lets soft sounds in, so I can hear everyone's voices. But if there's a big, loud explosion, it blocks the those decibels. So when you science. So you have to cover your ears when it's time to explode the device. All right. Now, first, I want to prove that it's going to be oxygen on one side, hydrogen on the other. So let's do oxygen first. Now, yesterday we did manganese dioxide, which is a black powder. And based on yesterday's experience, okay, too much talking, everyone. Let's close your screens. Close your screens. Finish later. Yesterday, I decided it's best to just use fresh manganese dioxide instead of the ones from several years ago, like scraping that bucket. Instead, I'm just going to add fresh powder, and it's a lot faster. So we'll be doing that first. And going ahead of myself, in here is not just water. It's something called glycerin, not nitroglycerin, glycerin. It's kind of like a glue. You can put this on your skin if you have like a cut. It makes it waterproof. A lot of street performers use this for making huge bubbles for like kids when they dip it in their solution. So glycerin's kind of like a glue, and then the other liquid that's in here is just dish soap. So I'm not going to blow up a balloon of gas, which some teachers do. Very dangerous. I'm going to be using soap bubbles, which is the same thing, but you won't have any leaks of gas like overnight if you store a balloon overnight. And also, if this soap bubble bursts, it's just soap. It's not like a piece of balloon is going to fly into your face. So it's a lot safer. So that's what's in here. And we'll do oxygen first. And based on your warm-up, you should know if it's truly oxygen. So looks like my reaction is still going from last period. Let's see if we have anything big enough. Not yet. So I'm going to drain the water that's in here as a result of the manganese dioxide. And I'm going to add my fresh manganese dioxide. So I add that. Immediately there's a response. Let's put some goggles on. All right, so first is oxygen. So definitely you can see something happening there. Now, based on our warm-up, there was a table that shows you what does oxygen do when there is a glowing splint. Now, we won't necessarily use a glowing splint because a paper towel also will act the same way. Let's see if that continue. So I'm going to light this. This will not explode. Okay, we've done this before. If you want to record, you can put the Chromebook here. Just only one maximum per table. I don't want like too many Chromebooks. So I'm going to light this paper towel, and then I'm going to blow it out. All right, no flame, right? But if I put this into oxygen, it relights, right? So not hydrogen, not hydrogen. Now let's go ahead and add hydrogen gas to this. I do want to make sure all the oxygen is popped because I don't want any early mixtures of hydrogen and oxygen. I'm just going to burn all the oxygen up. Okay. Now let's make the hydrogen gas. So hydrogen gas is made of metal. This is going to be zinc. And then something very dangerous called hydrochloric acid. So students will not be using this acid. Only teachers should be handling it because it's so strong. So I'm just going to go get that acid over here.
Give me a shout out.
even a smell test is dangerous with this. So this is hydrochloric acid. It's stored in special cabinets so that the gases that leak out won't be harmful. I'm going to add this to another flask, but it's only for hydrogen gas. That one's over here. Now, this is just a plastic tub, but there's water in here so that when this gets hot, I could at least cool it down and it won't break the glass open. And then I would have acid all over the table. So I'm just going to have it's called a water bath because it's a bath of water. But you don't put people in it. You put a container that needs to be cool. You can also put ice in it, but that's not necessary. So let's add some metal to this. Let's see if the acid that's already in here is strong enough, so I don't have to add more. And this is just like a gray rock called zinc. This is the same rock that's in your pennies. It coats your pennies. But let's see if we can make hydrogen gas just from the leftover acid from last period. Okay, it's starting to react a little bit. Let's see if that is going to be fast enough for us. It is not, so we're going to add a little acid. I still see some hydrogen, I still see oxygen bubbles in there, so I'm going to pop those because I don't want the hydrogen to mix, not yet. So I'm going to shake it up. Maybe this was faster. Okay, that's probably good enough. I regret putting ashes in there, but we have to move on nevertheless. Yeah, still too slow. So in goes the acid. Put this down. If you're close enough, you might see some white smoke coming out. It's very poisonous, so do not inhale.
Is it really?
We're gonna get the video.
Oh crap. Oh crap.
Okay, so this is hydrogen. And then we'll pop some of these to prove that it's hydrogen. Let's put it in the water bath. So what should happen when this flame hits the hydrogen? It should have a pop. They're small bubbles, so it's a small pop. Okay. How many heard the pop? Raise your hand. Okay, so we don't have to do that again. We're now going to mix the two to make a massive explosion. First, we're going to do hydrogen. And I want to fill it up to the first line. The first line is 1,000 milliliters of bubbles. Now, I'm going to shake it side to side to agitate and make collisions. You want more collisions if you want a reaction to speed up. I'm almost at the 900 mark. Alright, so once I hit 900, I'm going to put oxygen in. I'm going to alternate. So here's our oxygen. Let's set this aside. I think our oxygen probably slowed down by now. Alright, so we're going to add fresh magnesium dioxide. It's actually manganese dioxide.
Oh.
If you picked up on that. Okay, I'm going to add a little peroxide. A little slow for my expectations. And this is much safer than acid, so I'm okay with little spills like this. And I want to raise the level of bubbles to the second line. The first year I did this, the hydrogen bubbles would pop while the oxygen bubbles are in, so it was like a never-ending process of making gases back and forth. But this time, I added enough glycerin to make the bubbles sticky enough so they won't pop too fast. And we'll do this twice. There is a little bit of luck involved. It's hard to tell which bubbles is exactly hydrogen and which one's oxygen because they're both clear and colorless. But this is as good as it gets with soap bubbles. Maybe we can speed it up a little more for the sake of our hydrogen gas, because now the other flask is running out of hydrogen gas as I try to get enough oxygen gas. And what's unique about the gases is hydrogen makes smaller bubbles, oxygen makes bigger bubbles. Add a little more manganese dioxide. It's definitely slowing down. I want to get the bubbles up to this level. Question? No. Is there a question? I wonder if there's a leak of air. What I might have to do is just start adding hydrogen now. And then try to get it up to 13. Alright. So hopefully the mixture is 2 to 1. 2 hydrogen to every oxygen. Oxygen is faster than hydrogen at this point. Let's see, what should I add next? Let's add more hydrogen peroxide. I'm going to add a little more acid. We're pretty good, but I do want it faster. I don't want to waste our soap bubbles. What? Yeah, if it spills, we use baking soda to clean it up.
Why baking soda?
Baking soda absorbs the harmful parts of the acid. I want to keep this glass cool, so I'll place it in this flask. What's nice about having both reacting is hydrogen's definitely twice as fast than the oxygen. So our ratio should be a pretty good ratio. Someone tell me what happens when you get two hydrogen and 1 oxygen bonded together. Water. What's the formula of water? H2O. So the result of this is safe. There's nothing harmful after. Yeah, you want to wait for this. I'm about to activate this. Okay, so let's go ahead and pop what we have so far, and then we'll do this again with the with fresh products. When I tell you to cover your ears, cover your ears. Yeah, we're going to do the first one just to see how it is. Yeah, cover your ears now. Cover your ears. Don't scream, all right? You're going to panic the security. All right. Pretty good, right? Pretty good. Who wants to see it again? Okay, we'll do it one more time. Yeah, you gotta cover your ears, right? Okay, do the hydrogen first.
You did it? Huh?
So this one's not toxic. This one is just hydrogen gas. This is what happens when you put too much acid and metal at the same time. That filled up so fast so that we can probably do 3 of these. Yeah, we can do 3 of these. Because this filled up really fast.
So that means you were fine.
Something else that I wanted to make sure is the container is not made of glass. Yes, it's open-ended, but if you have a glass container, it could definitely be too strong of an explosion and you have glass everywhere. And then this plastic is also wrapped with tape, just in case the plastic does break, the tape will hold it together. So those are some considerations when I do this type of experiment. It's going to be hard to top that first explosion because that was pretty spot on 2-to-1 ratio, hydrogen to oxygen. But we'll just try again. It was definitely better than the last period because you actually see a fireball. Let's actually turn the lights off. Maybe we get a brighter flash.
Over there. Emma, you want me to start your video now? Yes, please. Yes, please.
Okay, this is definitely more soap than last time. As long as it's 2-to-1. If there's too much oxygen, it's going to be a softer explosion. If there's too much hydrogen, softer explosion. Okay, let's try it.
I like this. Cover.
Ah.
See, look, let's keep going.
I'm scared.
I'm
scared.
Here goes. That was pretty good. That's the same as last time. Okay, let's give our ears a rest now. Let's give our ears a rest. I want you to do your near pod while I start cleaning up. Why does the explosion happen and then stop? I want you to give me your opinion, right? Why does the explosion happen and then stop? So, near pod, join near pod.
Can we go back to our seat now?
Yeah, you can return to your seats. Yes. If it's empty for today, yeah, you can sit. Only for today.
Can we see the video?
All right, let me type the question in. Yeah, let's stop the recording.